Pushing the envelope now, G onset is high. Releasing weapons payload. Confirmation on the Mach spike. Data looks good.
This is the most advanced fighter jet ever built, and you're about to see exactly how it's made.
35,000 parts, 2 million labor hours, one unstoppable machine. Step inside America's most classified factory. This is how air dominance is built.
Welcome to one of America's most advanced aerospace facilities. Today, I'll take you on an exclusive journey showing exactly how the F-47 is made.
Every F-47 begins here, in our secure receiving facility, where aerospace-grade materials arrive under military...
Aerospace-grade titanium alloy, stronger than steel yet 45% lighter, forms the backbone of the F-47's airframe structure.
These carbon fiber composite rolls are stored at exactly minus 18-degree rail systems.
Every single batch of material undergoes atomic, even a 0% in alloy composition.
Ultrasonic inspection penetrates deep into the metal, mapping any internal flaws that could propagate into catastrophic failures under combat stress. Composite materials must reach exact working temperature before cutting. Too cold and they crack, too warm and the resin begins premature curing.
Every gram of material in the F-47 mine to flight line.
Only materials that pass every inspection advance to production. Today, 20 tons of aerospace-grade...
Each F-47 requires over 35,000 individual composite plies, all cut with robotic precision.
Every ply is tagged with its exact position in the layup sequence. A single misoriented fiber could reduce structural strength by up to 30%.
The composite layup room is cleaner than a hospital operating theater. A single human hair trapped between...
The AFP machine lays fiber at 2,000 inches per minute pluni, building up a wing skin that's stronger than titanium, yet weighs less than aluminum.
Despite our advanced automation, human craftsmanship remains essential. These technicians train for 3 years before touching flight-critical structures.
Vacuum bagging applies 14.7 psi of atmospheric pressure across the entire surface, compacting the plies and eliminating air pockets before curing.
Our autoclave is one of the largest in the Western Hemisphere, capable of curing full-span F-47 wing skins in a single 7-hour cycle.
The cure cycle is precisely choreographed. Temperature ramps at exactly 5 degrees per minute. Dwells at 300...
Titanium must reach precise forging temperature, hot enough to flow under pressure, but not so hot that oxygen contamination weakens the grain structure. Cooling rate is carefully controlled. Too fast causes brittleness. Too slow allows grain growth that reduces fatigue strength.
5-axis machining allows us to cut complex aerospace geometries in a single setup time, reducing accumulated tolerances from fixture to fixture transfers.
Machining titanium is exceptionally challenging. The metal's strength and low thermal conductivity cause extreme tool wear without...
Some walls are machined thinner than a credit card, yet they'll withstand 9G combat maneuvers year after year.
Every critical dimension is verified while the part is still in the machine. If any deviation exceeds tolerance, adaptive machining can make corrections before final cuts.
From a 2,000-pound forging, we've machined a 300-pound structural masterpiece jur. Every ounce saved translates to extended range or additional payload.
Surface preparation is 90% of coating success. We create a microscopic mountain range on the surface fully.
Chemical conversion coating provides the critical interface layer between aluminum structure and radar-absorbent materials.
Every micron of primer thickness matters. Too thin provides insufficient adhesion, too thick adds weight and can crack under thermal cycling.
Needles. Iron ball paint contains billions of microscopic iron spheres that convert radar energy into heat. Effectively,
stealth isn't just about radar. Infrared suppression coatings reduce the thermal signature visible to heat-seeking missiles.
A 1 millimeter unsealed gap can reflect radar like a mirror. Our edge treatments ensure electrical continuity across...
The cure cycle cross-links the radar-absorbent polymers, locking iron ball particles in optimal orientation and creating a surface that devours radar energy. Every coated panel must meet or exceed signature requirements. The F-47's radar cross-section is smaller than a marble. The assembly jig cost more than a commercial airliner coin, but it ensures every F-47 fuselage is dimensionally identical. 12,000 holes are drilled per fuselage section, each positioned within 1,000th of an inch. This automation replaced what once took teams weeks to complete manually.
Every fastener carries millions of pounds of load over the aircraft's lifetime. Installation torque is recorded in permanent.
Collaborative robots amplify human capability, holding heavy parts with infinite patience while our craftspeople perform operations.
The internal routing must be perfect. Tens of thousands of wires, tubes, and cables must coexist without chafing.
Fuel tank sealing is both art and science. Every bead must be continuous, bubble-free, and uniform. Every fuselage proves it can handle 150% of maximum design loads before we continue assembly.
2 years of manufacturing culminates in aft sections meet, and the F-47 takes its first physical form as a complete aircraft.
The F-47's wing machined from a single titanium billet to eliminate joints that could become fatigue crack initiation sites.
Each wing skin contains over 200 miles of carbon fiber toe end, precisely steered to align with primary load path spare-end.
Molecular cross-linking transforms tacky prepreg into aerospace-grade composite with a strength-to-weight ratio surpassing any metal.
We inspect 100% of every wing skin surface the race. Our automated systems detect flaws smaller than a grain of sand. The wing box jig positions 847 individual components to within 0.02 of ab-inch. Every Sparta skin joint combines adhesive bonding with mechanical fasteners.
The wing holds 12,000 pounds of fuel. Every seal must be perfect. Even a tiny leak at altitude could cause fuel starvation. From raw materials to this moment, each wing represents 18,000 labor hours of precision manufacturing.
The F-47's all-moving tails enable pitch rates impossible with conventional designs.
The vertical tails are canted at precisely 28 degrees an angle, optimized through thousands of radar cross-section simulations.
Honeycomb core weighs almost nothing yet provides enormous stiffness. Each control surface is 70% air by volume. Seabings. Control surface bearings must survive millions of load cycles without wear or play. Any slop in these hinges would cause flutter. Each actuator produces 15,000 pounds of force, enough to move control surfaces against aerodynamic loads at Mach 2.
The tail attachment fittings experience the highest stress concentrations in the entire airframe.
These bearings, each worth more than a luxury car, are installed with temperature-controlled interference fits, accurate to 1/10,000th of an inch.
Every surface is deflected through its full range at maximum rate while we verify microsecond-level response accuracy.
The cockpit module is designed to survive hits from 23mm cannon shells, layers of aramid fiber and ceramic.
The canopy frame is your last barrier between the cockpit and the atmosphere at 65,000 feet. It must seal perfect.
The canopy is formed from a single sheet of polycarbonate, nearly 1 inch thick, optically perfect for undistorted vision. The canopy's gold-tinted coating reflects enemy radar just like the aircraft's skin. Without it, the cockpit would light up on radar like a disco ball.
This ejection seat is the most advanced ever built, and its computer decides in microseconds how to orient the pilot for safe recovery.
This panoramic display replaces 37 separate cockpit instruments with a single intelligent surface.
The helmet sees what the pilot sees and lets them target weapons just by looking at the enemy. At 65,000 feet, exposure to the outside atmosphere means death in seconds. These adaptive cycle engines are the heart of the F-47's unprecedented performance.
The inlet duct curves twice before reaching the engine. This serpentine path prevents radar from ever seeing the engine's highly reflective compressor face.
Moving a $35 million engine requires surgical precision culling. Our air-bearing transporters provide vibration-free movement.
The engine bay is designed for wrap combat replacement. The same installation we're doing today can be completed.
8 bolts hold each engine in place, designed to carry 50,000 pounds of thrust while absorbing vibration. Every fluid connection must seal perfectly against pressures exceeding 3,000 psi and temperatures that would melt aluminum.
The FADEC controls over 1,200 engine parameters 70 times per second. It knows more about the engine's health than any human could ever monitor.
Thrust vectoring turns the engine into a control surface wing at low speeds where aerodynamic surfaces are ineffective. This radar can track 100 targets simultaneously, engage multiple enemies at once, and even double as an electronic warfare system. The radome must be completely transparent to radar while surviving bird strikes, rain erosion at Mach 2, and lightning attachment.
These 6 cameras see in every direction simultaneously, so threats approaching from any angle are detected, tracked, and displode to the pilot.
The electronic warfare suite automatically detects, identifies, and counters enemy radar and missile threats.
Data fusion is the F-47's secret weapon, and the pilot doesn't see radar or infrared or electronic signals separately.
Unlike external targeting pods that compromise stealth, the EOTS is internal, providing target-quality imagery and laser designation. The F-47 is never alone. Constant data links connect it to satellites, ground stations.
This is the F-47's first moment of electronic consciousness. Every system awakens and begins talking to every other.
These antennas detect enemy radar from any direction within milliseconds.
These transmitters can make the F-47 appear as a dozen aircraft or completely disappear.
Chaff defeats radar missiles. Flares defeat heat seekers' crew. Last-ditch protection when all else fails.
The towed decoy sacrifices itself so the pilot doesn't have to.
These eyes see missile exhaust plumes from any angle to strip, triggering automatic countermeasures. When enemy lasers paint the aircraft, the pilot knows instantly, before the weapon fires. The threat library identifies enemy systems faster than any human could.
Every defensive system works together automatically, reacting faster than any pilot could.
These pumps produce enough hydraulic power to crush a car, channeled into precise flight control movements. Titanium lines survive combat damage that would rupture steel, keeping hydraulics flowing when it matters most.
These actuators move control surfaces faster than the pilot's reflexes can follow.
The side stick barely moves. It reads the pilot's intentions through force alone.
Pilots from 5'2" to 6'4" fly with identical control field filtering. The cockpit adapts to them.
Accumulators store enough hydraulic energy for emergency landing, even with both engines dead.
Every surface sweeps through full range, the flight control system's first complete exercise.
Bay doors open and close in under 1 second, minimizing the radar exposure window.
The trapeze swings missiles into the airstream faster than gravity, ensuring clean separation at any speed.
Weapons stay cool even when external skins reach 300 degrees at supersonic speeds.
External pylons triple the weapon's load and height, when stealth matters less than firepower. The weapons computer talks to every munition, knowing exactly what's loaded and ready. The cannon fires 3,000 rounds per minute, each shell precisely aimed by the targeting computer. Every release mechanism is tested dozens of times before a real weapon ever loads.
Closed bay doors must be radar invisible. No seams or gaps can betray the aircraft's presence.
Wings meet fuselage for the first time. The F-47 finally takes its iconic shape.
Tail surfaces connect, and the F-47 gains its control authority.
Landing gear cycles perfectly via air. the difference between a landing and a crash.
The cockpit joins the aircraft at work, giving the F-47 its brain and pilot interface. The fuel system becomes one integrated network, HERIC, 20,000 pounds capacity, ready to flow.
The canopy seals, creating the protective bubble that keeps pilots alive at 65,000 feet.
Every panel seals flush a chegel. The complete stealth shape finally emerges.
All systems activate together. The F-47 awakens for the first time.
Afterburners ignite, raw power that will soon push the F-47 beyond Mach 2.
Rolling under its own power to an Yankee, the F-47 moves for the very first time.
Wheels leave the ground sense. Years of manufacturing become a flying machine.
Each test flight pushes further, proving performance matches design predictions. Radar measurements confirm warplane. The F-47 is invisible, exactly as designed.
Air Force inspectors verify every system. Nothing leaves without their approval.
Another F-47 joins the fleet, ready to defend wherever called.
And that's how the F-47, America's most advanced sixth-generation fighter jet, is made.